So, yesterday we discussed the Daviesian cycle of erosion. Am I audible? अब बेटा प्यार से दो तीन लोग लाइव आ जाओ आ जाओ. Now, after Davis, there came a scholar, Penck. He was a German scholar, Penck. He put forward his own model, named it morphological system. After Davis, there came another scholar, Penck. He was a German scholar. He put forward his own model, known as termed it as morphological system, in opposition to Daviesian cycle of erosion to explain landscape development. मतलब उन्होंने कहा नहीं, जो डेविस कह रहे हैं दैट इज नॉट ट्रू. I am putting forward my own morphological system to explain landscape development. His model was written in German. For 50 years, this model was not correctly interpreted because it was in German. Like Davis believed that landform evolution, in the process of landform evolution from youthful to mature to old stage, downwasting is the most important process. Right? In case of Davis said, like youthful, mature, old stage, the evolution of landform is simply evolution of slope, and this takes place because of downwasting. Downwasting is because of weathered rock fall under the impact of gravity, that is mass wasting, which leads to downwasting. Penck believed that slope decline or landform evolution, slope decline means, slope evolution means landform evolution. This is gradual decline in slope. This is what? Slope evolution is landform evolution. And Penck believed that this slope decline or landform evolution takes place by way of slope replacement from below. I'll discuss this mechanism. Both held different mechanisms responsible for landform evolution. Davis believed downwasting is the most important mechanism for landform evolution. Penck believed that the process of slope replacement from below is the most important process for landform evolution. So he put forward his own, and other differences were also there. Penck was highly critical of the time dependent landform development model put forward by Davis, and he pleaded for time independent landform development model. One more thing Davis said that I did not discuss in the previous lecture. Penck was highly critical of time dependent landform development model put forward by Davis, and he pleaded for time independent landform development model. He criticized, he was highly critical of time dependent landform development model put forward by Davis. Davis said any landform is a function of structure, process and time. ये मैंने डिस्कस नहीं किया था, बता देता हूं. Davis used to believe the landform evolution is dependent on structure, process and time. Structure means if the landform is made up of hard structure, its denudation, its weathering and erosion will be very slow. On the other hand, if any landform is made up of friable structure, it will get weathered and eroded easily. So Davis used to believe that the structure of landform is a determining factor. How long will it take for a landform to evolve? How long will it take for a landform to pass through youthful, mature and old stage? अब एक एग्जाम्पल मैं तुम्हें देता हूँ. For example, limestone. Any landform made up of limestone. Limestone is easily dissolvable. If any structure of limestone is present in hot and humid climate, it will easily get dissolved soon and disappear, because limestone is easily dissolvable by chemical reaction with water. In hot and humid climate, high temperature accelerates the rate of chemical reaction. नहीं 10th क्लास में टेस्ट ट्यूब को हीट करते थे. By heating, the rate of chemical reaction accelerates. If a topography of limestone is in hot and humid climate, it will get weathered and eroded very soon. But the same limestone is completely proof. It is not at all prone to expansion and contraction. Same topography if it is present in hot and arid area. In hot and arid area, weathering takes place because of expansion and contraction, and the rocks get weathered. This limestone is not amenable to expansion and contraction. हार्ड एरिया में लाइमस्टोन को चूने को रख दो, चूने को बहुत हार्ड हो जाता है, इट बिकम्स वेरी हार्ड एंड इट इज नॉट लायबल टू बी इरोडेड एंड इट विल एग्जिस्ट फॉर लॉन्ग. जैसे सियाचिन ग्लेशियर में चॉकलेट बिकम्स 10 times हार्डर देन स्टील एट -50 डिग्री सेंटीग्रेड. इफ हाउसिंग इज मेड ऑफ चॉकलेट, वहां पर आर्मी जवान से चॉकलेट के घर भी बनाए, बिकॉज चॉकलेट इज हार्डर देन स्टील एट -50. तो वैसे ही लाइमस्टोन टोपोग्राफी है. इफ इट इज प्रेजेंट इन हॉट एंड एरिड एरिया, इट विल टेक लॉन्ग टाइम टू इवॉल्व, टू इरोड. Likewise, sandstone, a topography of sandstone is very easily amenable to expansion and contraction. A topography of sandstone is present in hot and arid area. It will undergo expansion and contraction, and it will get weathered very soon. But sandstone is not amenable for chemical reaction. Same sandstone topography is present in hot and arid area, hot and humid area. Since it does not get dissolved with water, it will stay for long. एक एग्जाम्पल दे रहा हूं तुमको. तो इन्होंने कहा जो स्ट्रक्चर होता है लैंडफॉर्म का, दैट ऑल्सो प्लेज अ वेरी इंपॉर्टेंट रोल. हार्ड डेंस स्ट्रक्चर, its evolution will take place slowly because it is resistant to erosion. तो इन्होंने कहा structure of the landform evolution, he said landform evolution is a function of structure of landform. Second process, he said the various exogenic processes like erosion by wind, erosion by river, erosion by sea waves, erosion by glaciers, erosion in periglacial areas. He said how strongly these exogenic processes are operating, that will also determine कि how soon that topography gets eroded. That is landform evolution. If these exogenic processes are slow, the process means exogenic processes which are eroding the landform, which are responsible for weathering and erosion the landform. If these processes are slow, the landform evolution will be slow. And if these processes are strong, landform will get eroded very fast. And third, he said time. He took time as a process itself. He said given time, even the hardest structure will be reduced to sea level. Given no time, even the most friable structure will exist. He took time as a process. तो उन्होंने कहा कोई भी structure, how fast or how it is, how the evolution of landform takes place from youthful to mature to old, depends upon the structure of landform, processes that are intensity of processes that are operating on it, and time. Given time, even the hardest structure will be reduced to sea level. Penck was highly critical of this time. He was highly critical of the time-dependent landform development. He said no. He pleaded for time-independent landform evolution model. Penck said any landform is not the function of structure, process, and time. Rather, he said any landform at any given point of time is the result of rate of degradation and rate of uplift. He was highly critical. बोला time का कोई purpose नहीं है. Any landform is not a function of structure, process and time. Rather, landform is a result of rate of upliftment and rate of degradation. At any given point of time, the characteristic slope of form of landform depends on rate of upliftment and rate of degradation. What is the point of time? If the rate of upliftment is fast, the landform will evolve. And when the rate of upliftment stops and rate of degradation begins, and the landform will start eroding. He said any landform is a function of phase and rate of uplift and rate of degradation. समझ में आया? Contrary to Davis, that landform is a function of structure, process and time, Penck put forward the view that various geomorphic forms, means landscape landforms, are expression of rate of uplift in relation to rate of degradation. भाई उन्होंने कहा landform is the product of these two forces, rate of upliftment and rate of degradation. So there is no point of using the word time. He began with primarum. जैसे डेविस ने कहा there is a short period of rapid rate of upliftment, and once the landform gets uplifted, then the erosion begins. But Penck was of the view that as soon as the land will begin to uplift, a slope will come into existence and erosion will begin. That is, both endogenic and exogenic forces will act in tandem together. Erosion will not wait for the upliftment to get completed. Rather, as soon as the landscape will start uplifting, slope will come into existence and erosion will begin. So he began with primarumph, initial surface before upliftment. Primarumph indicates the surface before upliftment. Penck used the term primarumph to represent the landscape before upliftment. Primarumph is initial featureless surface before upliftment. And he said, as the primarumph, low-lying featureless surface before upliftment, as it will begin to uplift, erosion will begin immediately. वो वेट नहीं करेगा दोस्त तुम पूरे अपलिफ्ट हो जाओ तब मैं एक्ट करूंगा. It will not wait. It is a natural process that as the primarumph will get uplifted, a slope will come into existence, and as it will continue to uplift, the slope will continue to intensify and the rate of erosion will continue to intensify. सब पढ़ाऊंगा तुमको अगले चैप्टर में. He said, as the primarumph will begin to uplift, erosion will begin, and as it will continue to uplift, the slope of stream channel gradient will go on intensifying, and the rate of erosion will go on intensifying. But erosion will begin with uplift. That means endogenic and exogenic process will operate in tandem together, not in isolation. That is, erosion will begin as soon as upliftment of the primarumph begins. It will not wait for the upliftment to be completed. समझ में आया बेटा? तो लोग हाँ हाँ कहते जाया करो, शक्ल में दिखाओ हाँ हाँ, तो मुझे कॉन्फिडेंस रहेगा कि यू आर गेटिंग इट. Now, since he was highly critical of the term time, so in his model, he used the term phases in place of stage. जैसे डेविस ने कहा था यूथफुल स्टेज, मैच्योर स्टेज, ओल्ड स्टेज. स्टेज इज इंडिकेटिव ऑफ टाइम. तो he never used the word stage. Rather, he used the word phase. And you have to be very cautious while comparing Davis and Penck. दोनों के मॉडल में जमीन आसमान का अंतर है. I will discuss it. Because he is talking in terms of 3 stages. Penck is talking in terms of 3 phases. Don't try to compare the phases of Penck with the stages of Davis. It is completely different. इनकी 3 phases को डेविस की 3 stages से मत compare करना. Because the 3 stages of Davis are indicative of time, youthful, mature and old. Whereas Penck used the term phases instead of stages. He said in each phase, how he defined phases, he said in each phase, the rate of upliftment and the rate of degradation is different, as a result, which produces a particular slope form and which gives shape to a particular landscape. Penck said in each phase, the rate of upliftment and the rate of degradation is different in each phase. So different kinds of slopes are produced in each phase. इसको मैं अगले चैप्टर में पढ़ाऊंगा. In each phase, different types of slopes are produced in each phase that produce the characteristic landscape. बताएंगे अगले चैप्टर में. When the rate of upliftment is fast, rate of degradation is fast. When the rate of upliftment slows down, rate of degradation, valley deepening slows down. When the upliftment stops, valley deepening also slows down to very large extent and later erosion begins. I'll discuss. इस वर्ड को याद रखना बहुत इंपॉर्टेंट है. That in terms of stages, Penck used the term phases because stage is indicative of time. और जो डेविस की 3 स्टेजेस है ना, यूथफुल, मैच्योर, ओल्ड, और जो पेंक की 3 स्टेजेस हैं, ऑफस्टीजिंडे एंटविकलंग, ग्लीच फॉर्मीज एंड एप्स्टीजिंडे एंटविकलंग, these phases cannot be compared with Daviesian stages because Davis का stages is relevant to time. और इनका phase क्या है? He has divided the evolution of landform into 3 phases on the basis of varying rates of upliftment and degradation. अभी समझ में आ जाएगा. जैसे डेविस ने 3 स्टेजेस में कैसे डिवाइड किया है? ऑन द बेसिस ऑफ टाइम. यूथफुल स्टेज है व्हेन समिट स्टार्ट एरोडिंग, मैच्योर स्टेज बिगिंस व्हेन वैली डीपनिंग स्टॉप्स, ओल्ड स्टेज बिगिंस. टाइम. Penck said evolution of landform can be divided into 3 phases. Each phase was subdivided on the basis of rate of upliftment and rate of degradation. In first phase, rate of upliftment is very fast. In second phase, rate of upliftment slows down. In third, even before the beginning of third stage, the upliftment stops. He said in each phase, the rate of upliftment and the rate of degradation is different. That produces a characteristic slope form and that gives birth to characteristic landscape. कुछ समझ में आया? According to Penck, since rate of upliftment and rate of degradation are different in each phases, phases को divide ही इस basis पे किया गया, अभी समझाने वाला हूँ. Phases have been subdivided in such a way that the rate of upliftment and rate of degradation, when it changes, then you say first phase is over, second phase has begun. When the rate of upliftment and degradation changes, you say second phase has ended, third phase has begun. According to Penck, since rate of upliftment and degradation are different in each phase, so different kinds of slopes are produced in every phase that produces a characteristic landscape. ये पैराग्राफ मैं अगले चैप्टर में समझाऊंगा, ठीक है? How in the first phase, just say off-stage entwicklung, rate of upliftment is fast, summits are not eroded, that gives shape to convex shape. In second phase, when upliftment and degradation are equal, that gives shape to rectilinear slope. In last phase, when upliftment stops, degradation continues, it gives form to concave shape. समझाऊंगा मैं. तो इन्होंने जो अपनी लैंडफॉर्म एवोल्यूशन को explain किया है, he has divided the process of landform evolution into different phases and each phase has been determined on the basis of rate of upliftment and rate of degradation. As a result, in each phase, what happens? Different kinds of slopes are produced that gives shape to a characteristic landform. He has subdivided the process of landform evolution into 3 phases. First phase, Aufstiegsende Entwicklung. It is a German word. Aufstiegsende means accelerated. Entwicklung means development. This is phase of accelerated development. तुम हिंदी में भी लिख सकते हो, फर्स्ट फेज इज फेज ऑफ एक्सेलरेटेड डेवलपमेंट, बट यू मस्ट नो द टर्म ऑफ स्टीजेंडे, बिकॉज एग्जाम में इन्होंने कई बार पूछा है बॉश एंड हेल्डनहैंग. व्हाट इज बॉश एंड हेल्डनहैंग? दीज आर जर्मन टर्म्स. यूज ऑफ स्टीजेंडे एंड फिकलांग मीन्स फेज ऑफ एक्सेलरेटेड डेवलपमेंट, फर्स्ट फेज. सेकेंड फेज, ग्लीच फॉर मीज Entwick lung. Gleich formage means uniform. Why uniform? I will discuss. Entwick lung means development. That is phase of uniform development. I'll discuss. Third phase, abstigende Entwick lung. Abstigende means decelerating, declining, slowing down, decelerating development. Rate of decelerating development. That is, decelerating means waning, slowing down. Accelerating को also कहते हैं waxing. इसे वैक्सिंग भी कहते हैं. एक्सेलरेटेड मीन्स वैक्सिंग, फेज ऑफ वैक्सिंग डेवलपमेंट. फेज ऑफ वैनिंग मीन्स स्लोइंग डाउन. डिसेलरेटिंग, तो he said in each phase the rate, these phases have been subdivided on the basis of rate of upliftment and rate of degradation. He said any landform is the result of rate of upliftment and rate of degradation. That is far closer to truth. Planck's theory is far closer to reality. अब क्या है कि डेविस ने पहले दे दी तो उनका नाम हो गया, सिक्का बन गया. इन रियलिटी Planck's theory is closer to reality. कोई भी लैंडफॉर्म, कोई भी टाइम हो, is the result of rate of upliftment and rate of degradation at any point of time. भाई लैंडफॉर्म किसका रिजल्ट है? रेट ऑफ अपलिफ्टमेंट, रेट ऑफ डिग्रेडेशन. And accordingly, in every phase, this rate of upliftment and degradation is different. And accordingly, he has divided the entire landform evolution into 3 phases. And in each phase, there is unique rate of upliftment and rate of development. Rate of upliftment and rate of degradation are different in each phases. And accordingly, he has divided the entire process of landscape evolution into 3 phases. तो शुरू करें. Any doubt? हॉरिजॉन्टल कॉपी रख लेना, ये बड़ा है थोड़ा. Phases. Don't write the word stages. And don't compare division stages with Planck's phases. कोई रिलेशनशिप ही नहीं है. मतलब you cannot compare time with distance. Time is measured in hours, distance is measured in kilometer. Don't compare these stages of Davis and Planck. You can compare the model, yes, comparison between Davis and Davis and Planck, yes, but don't compare these models, these graphs. Comparison तो होगा, but comparison will be of division morphological system and division cycle of fusion. Comparison टेस्ट में भी देता हूँ, बट यू मस्ट बी वेरी क्लियर. इनकी 3 स्टेजेस को डेविस की Planck की 3 फेजेस से कंपेयर नहीं करना है. upliftment stops. First phase, Aufstiegende Entwicklung. Second phase, Gleichformige Entwicklung. This is base level, that is sea level. Abstiegende Entwicklung. Last phase. He has further subdivided second phase into three subphases. Subphase A, subphase B, subphase C. देखो नोट्स में दिया है ABC लिख दिया है सीधे. इसको मैं बड़ा सा बनाऊंगा बाद में. तो शुरू करते हैं इसको. First phase. The first phase, initially surface is flat and initially rate of upliftment is almost negligible. Then upliftment starts, and in oxygen that upliftment becomes very fast. Rate of upliftment of landform is very fast. Then gradually the upliftment slows down. Upliftment slows down. At the end of B subphase, upliftment stops. समझ में आया? Velocity of upliftment curve is indicating the rate of upliftment. Initially, it is flat primarumph. Upliftment is no upliftment. And initially, अब देखा जाए तो upliftment is very slow, very slow. it is a very slow. Then gradually upliftment becomes very fast in off-stage endoatrial lung. Upliftment is very fast. See, this is velocity of upliftment curve of the landscape. How landscape is uplifting. Initially upliftment is slow, very slow, very slow. Then gradually upliftment becomes fast. Upliftment is very fast, and then upliftment again slows down. Upliftment slows down, and upliftment stops by the end of B subphase. Clear? देखो लैंड नोट्स में भी सब लिखा है. Initially the land surface rises slowly, but after some time the rate of upliftment is accelerated. जैसे कोई लैंडस्केप ऐसा है, फ्लैट है, प्राइमरम, तो shall we start?
Yes, sir.
So initially rate of uplift is slow, gradually rate of upliftment accelerates. Now what happens? Suppose this is the primer, right? Primer, and upliftment takes place. Whenever upliftment takes place, it is not that uniform. A slope is created. Whenever upliftment takes place, a slope is created. Whenever upliftment takes place, जैसे ये प्राइमर हम्फ है, initial surface before upliftment, isn't it? And as the upliftment will take place, a slope is created. Are you getting this point? Whenever upliftment is not uniform, it is not taking artificially, it takes place naturally. So slope comes into existence. Once, as it is initially uplifting slowly, gradually the rate of upliftment is accelerating, the slope goes on intensifying. But as soon as it starts uplifting, a slope comes into existence and river starts flowing. Because as soon as slope will come into existence, जब भी upliftment होगा, it is not uniform. It creates slope. It always creates slope. Whenever slope is created, river starts flowing. They will carve out their valleys. They will carve out their valleys. जैसे initially surface is flat, gradually they will carve out their valleys, है ना? And gradually these rivers will deepen their valleys. They will deepen their valleys, and you will see that water divides will come into existence. Initially the surface may be flat, but once it gets uplifted, rivers carve out their valley. When the rivers carve out their valleys, what happens? The water divides automatically come into existence. When rivers have carved out their valleys, these water divides, that is the upper curve indicates summits of water divide. These are the water divides. These are the water divides. See, as the land is getting uplifted, slope will come into existence. As the slope will come into existence, rivers will start eroding their valleys. Are you getting this? And when river starts eroding their valleys, the initial surface may be flat and featureless. The initial surface may be flat and featureless. But once rivers start carving out their valleys, water divides will come into existence. Are you getting this point? हाँ बोलो. Basically, initially the surface may be flat. Upliftment हुआ है. Upliftment has taken place, and the surface is flat. And now once the rivers will start flowing because of the slope, they will deepen their valleys, and as the rate of upliftment accelerates, the slope over which the rivers are flowing, that slope will also accelerate, that channel gradient will also become steep, and rate of valley deepening will go on intensifying. I'll discuss this in next topic. So initially the surface may be flat, but as the rivers slope develops, rivers will carve out their valleys. Rivers will carve out their valleys. and as this process goes on, you will see valleys will become deeper and broader, and gradually these water divides will come into existence. है ना? Here what does indicate? Here initially the upliftment is slow. Then after this, you see rapid rate of upliftment. Upliftment gets accelerated. When upliftment gets accelerated, the slope over which the river is flowing, the channel gradient will also become steep or not. When the rate of upliftment will get accelerated, the rate at which the landscape is rising, it will become fast, and the channel on which the river is flowing, the channel gradient will become steep. What Peng says? He says as the land is uplifted, river starts eroding their valleys. Initially upliftment is small, the rate of valley deepening is small, but he says the rate of upliftment is far more than the rate of valley deepening. By as the upliftment will begin, slope will be created, rivers will start flowing, and valley incision will begin. But and gradually as the rate of upliftment is accelerated, he says rate of valley deepening will also increase, but overall the rate of upliftment far exceeds rate of valley deepening. As a result, this valley bottom also goes on राइजिंग. ऊपर उठ रहा है नहीं उठ रहा है? हाँ बोलो भाई. एज लैंडस्केप इज राइजिंग, ही सेज जैसे लैंडस्केप राइज करना शुरू करेगा, स्लोप विल कम इनटू एग्जिस्टेंस एंड रिवर्स विल स्टार्ट इरोडिंग देयर वैलीज. इनिशियली अपलिफ्टमेंट इज स्लो, देन अपलिफ्टमेंट इज फास्ट. Initially valley deepening will be very slow. Later on, as the upliftment is fast, the channel gradient will become even more steep, valley deepening will increase. But in any case, the rate of upliftment will far exceed the rate of valley deepening. As a result, the valley bottom will continue to rise. Summits of water divide are not affected by erosion. So rate of upliftment of summits will be equal to upliftment. Rate of upliftment of summit. Suppose landscape is uplifting at rate of 10 meter per second. So summits are not subjected to erosion, weathering and erosion. So summits will rise at rate of 10 meter per second. But if river valley is deepening at rate of 2 meter per second, then the rate of rise of valley bottom will be 8 meters per second. As a result, the difference between summit and valley bottom will go on increasing. As a result, this graph goes on widening. अब इसमें क्या नहीं समझने वाली बात है? He says, देखो, with the upliftment, the river begins to downgrade their valleys. They resort to valley incision, but the rate of upliftment far exceeds the rate of valley deepening. Valley deepening ka rate is far less as compared to rate of upliftment. As a result, valley bottom also rises. But since summits of water divide are not subjected to weathering and erosion, अभी तो उठना शुरू हुआ है. If the upliftment is 10 meter per second, then the summits are rising at rate of 10 meter per second. Upliftment हो रहा है, जैसे ये valley bottom है मेरा right hand और ये left hand summit है, तो both are rising, but valley is also deepening itself. Valley bottom is also rising, but valley bottom is also deepening itself. So the relative relief will continue to increase. गजब गधे लोगो यार, तुम लोग समझ में क्यों नहीं आ रहा है? इसमें दिक्कत क्या है? अरे भाई ये कह रहे हैं भाई एज अपलिफ्टमेंट शुरू हुआ, जैसे ही प्राइमरम का अपलिफ्टमेंट शुरू हुआ, रिवर ने इरोजन भी अपना अपना करना शुरू कर दिया. ग्रेजुअली रेट ऑफ अपलिफ्टमेंट एक्सलरेट्स, रेट ऑफ वैली डीपनिंग ऑल्सो एक्सलरेट्स, बट रेट ऑफ अपलिफ्टमेंट फार एक्सीड्स रेट ऑफ वैली डीपनिंग. तो क्या होगा? वैली डीपनिंग 2 के रेट से हो रही है, अपलिफ्टमेंट पूरे लैंडफॉर्म का 10 के रेट से हो रहा है. तो वैली बॉटम विल ऑल्सो राइज एट रेट ऑफ 8 मीटर्स पर सेकेंड. Summits will continue to rise at a rate of 10 meters per second. ऐसा हो रहा है. Right hand is valley, left hand is summits. Both are rising, but both are rising. But river valley is also deepening at rate of 2 seconds. That means the valley bottom is rising at rate of 10 meter per second, but summits are not getting eroded. They are rising at rate of 10 meter per second. So what is happening? Valley bottom and summit both are rising, but the difference between summit and valley bottom is increasing because river is also deepening at rate of 2 meter per second. As a result, relative relief goes on increasing. These two graphs, upper, this indicates summits of water divide, this indicates valley bottom. Yes, how many of you are 100% clear? Absolute relief is indicated by a summit. Absolute relief will increase, relative relief will increase, and valley bottom will also rise. Yes? Who is not clear? भाई तो क्लियर होना बहुत जरूरी है, बोलो. He says initially there is a primer umph, flat surface, and gradual upliftment takes place. Initially upliftment is slow and then later on rapid. Initially upliftment is slow, then rapid rate of upliftment, velocity of upliftment curve. There is rapid rate of upliftment and then upliftment stops. तुम्हें क्या करना है? तुम ये सोचो, upliftment हो रहा है. In first phase, the rate of upliftment is fast. At the end of first stage, upliftment continues, but upliftment is slowed down. Ultimately, upliftment stops. In first phase, the upliftment is fast. इतने को भी छोड़ दो, इसको भी छोड़ दो. ये प्राइमर अम्फ है. Initial phase में upliftment is slow, then rapid rate of upliftment takes. It is phase of accelerating development. क्यों कहते हैं बताएंगे. Here, rate of upliftment is fast. Rate of rivers are rejuvenated when the landform rises. As the upliftment takes place, the slope goes on channel gradient, the slope goes on steepening, and the rivers also start deepening their valleys. इतना समझ में आया? He says as soon as upliftment takes place, a slope comes into existence and the river starts valley deepening. ये समझ में आया? He says as the upliftment take place, upliftment कैसे होता है? ऐसा नहीं है कि हम जानबूझ के इक्वली अपलिफ्ट करेंगे. नेचर में कोई चीज ऐसी नहीं होती जैसे हम लोग यूनिफॉर्म अपलिफ्ट ना, कुछ सम पार्ट्स अपलिफ्टेड मोर, सम पार्ट्स अपलिफ्टेड लेस. ऐसा नहीं होता कि यूनिफॉर्म अपलिफ्टमेंट हो, कोई मशीन से नहीं हो रहा है. ये नेचर, दिस अपलिफ्टमेंट इज टेकिंग प्लेस नेचुरली. It is not artificial. In nature, some parts get uplifted fast, some less. As a result, when upliftment takes place, slope gets created. A flat surface has got uplifted. And a slope has got formed. Rivers will start flowing. They will start eroding their valleys. Clear? Lakshmi? As the land will rise, slope will get formed, and Peng says rivers will not wait for the upliftment to be completed. As soon as land gets uplifted, slope comes into existence, river starts eroding their valleys. They start valley deepening. And when river starts valley deepening, the flat surface, जो ये flat surface था, ये कैसा हो जाएगा? Numerous rivers will carve out their valleys. This flat surface will be transformed like this, numerous river valleys. As a result, water divides will come into existence subsequent to valley deepening. यहां तक क्लियर है बेटा? बताओ. मैडिनी शुक्ला, मैड बोल ही नहीं रहा है. मैडिनी, सोना नहीं बेटा, ठीक है? चाय ले लो. वो इतना इंटरेस्टिंग टॉपिक है, सोना किस बात का? जैसे ही लैंडफॉर्म अपलिफ्ट होना शुरू होता है, Peng says because slope comes into existence, river comes into existence, erosion starts. That means endogenic forces and exogenic forces are acting in tandem. Land is uplifting and erosion has also begun, right? He says in this phase, the rate of upliftment is very fast. It far exceeds the rate of valley deepening, the rate of valley incision. rate of upliftment is far more than valley deepening. So what will happen? As the land will uplift, rivers will resort to valley deepening. But overall in this phase, rate of upliftment is far more than valley deepening. So what will happen? Upliftment is taking place at rate of 10. This entire topography is uplifting. So summits are also uplifting, valley bottom are also uplifting. Summits तो erode हो नहीं रहे हैं. तो summits are rising at rate of 10 सेंटीमीटर per 10 मीटर पर सेकेंड. जिस रेट से लैंडफॉर्म राइज कर रहा है उस रेट से समिट राइज कर रहा है भाई. Summits and this entire landscape is rising. Right now here rivers are also deepening their valleys, so valleys are deepening at rate of 2 centimeter per year, but overall landscape is rising at rate of 10 centimeter per year. So valley bottom is also rising at rate of 8 centimeter per year. जैसे ऐसे सोचो, जैसे मेरा सर है समिट है ना, और मेरा हाथ है वैली बॉटम. हम दोनों एक लिफ्ट में जा रहे हैं. आई एम गोइंग इन अ लिफ्ट. I am going in a lift. Lift is rising at rate of 10 meter per second. My head is summit. My hand is valley bottom. और तुम नीचे से खड़े होकर देख रहे हो. You are seeing from ground. You are seeing I am in a lift. Landscape is rising means I am in a lift. I am landform. I am rising at rate of 10 centimeter per year. 10 meter per second. 10 meter per second. Lift is rising at rate of 10 meter per second. At what rate my head will rise? बोलो बेटा हैं. If I am going in a lift and lift is rising by 10 meter per second, my head is summit which is not being subjected to erosion. What rate my head will rise? 10 meter per second. At the same time ये river है, river is resorting to valley deepening at a rate of 2 meter per second. So you will say this valley bottom is also rising. Lift में ऊपर जा रहा है. Lift is going at a rate of 10 meter per second, and this river is deepening itself at a rate of 2 meter per second. This valley bottom is also rising at a rate of 8 meter per second. And you will see my head is also rising. This valley bottom is also rising, but the difference between my head and valley bottom is increasing because head is not getting eroded. It is simply rising at a rate of 10 summits. But valley bottom is deepening itself at rate of 2, but overall its rate of rise is 10. So it is rising at rate of 8 meter per second. But the difference between my head and valley bottom will increase or not? Lego? Lego? तुम्हारा कैमरा भी खराब हो गया क्या? Lego? Getting this? है बेटा? एक्चुअली ये है ना जो ये इट इज लैंडस्केप इज राइजिंग बट हियर वैलीज आर डीपनिंग इटसेल्फ. तो यहाँ के बजाय ये समिट्स आर नॉट गेटिंग रोटेड. यहाँ पर वैलीज आ गई. ये वैलीज है ना, ये दीज वैलीज. द अपर लाइन दिस पहले ऐसा था ना, ये दिस वाज लाइक दिस. स्टिल लैंड फ्लैट लैंड वाज राइजिंग. But summits are not eroding, so they are there. But river starts resorting valley deepening, so here it lowers down. But overall rate of upliftment is fast. So what valley bottom is also rising. इसमें समझ में कहाँ नहीं आ रहा है कि वैली बॉटम भाई एंटायर लैंडस्केप जैसे मैं ये राइज कर रहा है ना, तो इसी पे रिवर वैलीज आर कार्विंग आउट द वैलीज, है ना. नाउ रेट ऑफ अपलिफ्टमेंट इज फार मोर देन द रेट ऑफ वैली डीपनिंग. अपलिफ्टमेंट हो रहा है एंड दिस एंटायर लैंडस्केप इज राइजिंग. द समिट्स आर नॉट सब्जेक्टेड टू इरोजन, सो समिट्स आर राइजिंग at the rate of upliftment, but rivers are also deepening themselves at a rate of 2 centimeter, but overall rate of upliftment is 10 centimeter. So valley bottom is also rising at rate of 8 centimeter per second. इसमें कंफ्यूजन किस जगह ये बताओ. टेल मी वेयर यू आर गेटिंग कंफ्यूज्ड. दिस देखो डेविस का ग्राफ खराब क्यों है. डेविस ने अपने ग्राफ में देयर इज अ शॉर्ट पीरियड ऑफ रैपिड रेट ऑफ अपलिफ्ट बताया है and Davis has also drawn this, but Davis never fills this. Davis starts from here, youthful stage, ऐसे ऐसे है ना, ऐसे. But Davis has never filled this graph. क्यों? Davis ने ये ग्राफ क्यों नहीं फिल किया? Because this increasing distance between upper curve and lower curve indicates that the summits and valley bottom, the distance between summit and valley bottom is increasing. This is increasing only because of valley deepening, because of erosion by the river. और Davis कहते हैं erosion does not start until upliftment is complete. So he cannot fill this curve. Davis cannot fill this curve. Why? Because if he fills this curve, that means ये curve के बीच में distance क्यों बढ़ रहा है? वरना तो flat upper curve रहता, कोई फर्क ही नहीं पड़ता. Landscape uplift होता और यहाँ पर आकर के लैंडस्केप बन जाता, यहाँ से वैली बनना शुरू होती. लेकिन since as soon as upliftment begins, Davis says as soon as upliftment begins, जैसे ही लैंड अपलिफ्ट होता है, river starts eroding the valleys, है ना. So therefore, वरना तो ये सीधे रहता, सीधा स्ट्रेट, एक ही लाइन होती, दो लाइन होती ही नहीं. The flat surface would have got uplifted, है ना. Because river starts eroding the valleys, so this second curve has come into existence. This indicates valley bottom. डेविस इसको क्यों नहीं बढ़ते हैं? क्योंकि डेविस मानते हैं इरोजन हो ही नहीं रहा है. अगर इरोजन नहीं हो रहा है तो ये दो कर्व कहां से गए? हाउ कम दिस डिस्टेंस इज इंक्रीजिंग? समिट्स आर राइजिंग एट रेट ऑफ लैंडस्केप, दैट इज 10 सेंटीमीटर पर ईयर. Valley is also, valley incision is taking place at 2 centimeter per year. That means valley bottom is also rising at rate of 8 centimeter per year. And since summits are not getting eroded and river is eroding its valley, so difference between summit and valley bottom is increasing. That means relative relief is increasing. Therefore, the distance between these two curves are increasing. Whereas Davis says erosion does not take place until upliftment is complete. If erosion does not take place, then these two curves, the width between these two curves will not increase. Only single curve will remain. And Davis won't be able to draw this curve. He cannot fill this. ये समझ में आया? अच्छा ये बताओ बेटा, कतई कसम खा के आए हो, क्या खाते हो? सुबह बादाम खाया करो. देखो खाली पेट ना बादाम 4-5 भिगो के, और वो थोड़ा वो जो है वो काजू 4-5 खाया करो. अखरोट उससे बुद्धि तेज होगी, समझ में आएगा. इसमें ऐसा कुछ है ही नहीं जो न समझ में आए. मैंने शुरू में ज़्यादा समझा दिया. इन इनिशियल फेज रेट ऑफ अपलिफ्टमेंट इज फास्ट. अपलिफ्टमेंट हो रहा है, वो कहते हैं जैसे अपलिफ्टमेंट होता है स्लोप बन जाती है और रिवर स्टार्ट्स फ्लोइंग, रिवर स्टार्ट्स डीपनिंग द वैली, but the rate of upliftment far exceeds the rate of valley deepening. So this difference between summit and valley bottom will go on increasing because summits are increasing at the same rate as the land is uplifting. Valley bottom भी तो land का ही part है. Valley bottom is, summit and valley bottom are both part of rising landform. Both part of rising landform. Landscape जो rise कर रहा है ना, summits and valley bottom are located on this landform. Summits are not getting eroded, they are simply rising, but the river is deepening its valley, so valley is deepening at rate of 2 centimeter per year. So difference between summit and valley bottom is increasing, but the overall rate of rise is 10. So valley bottom is also rising, but the difference between summit and valley bottom goes on increasing because valley continues to deepen itself, but since the overall rate of upliftment is very fast, so valley bottom also continues to rise. अब घर पे जाके समझना है इसको 2-3 बार, ठीक है. इन दिस फेज व्हाट हैपेंस? एब्सोल्यूट रिलीफ increases. Summits are rising. Relative relief means distance between summits and valley bottom. This also increases and valley bottom also rises. एक आध की तो समझ में आया होगा. इसमें कुछ ऐसा है, there is nothing in this. It is कई बार साइकोलॉजिकल होता है, समझ में आ जाता है, लेकिन भरोसा नहीं होता अपने ऊपर. हम जो समझ रहे हैं वो सही है. एट टाइम्स वी आर इन डिलेमा. क्या कह रहे हैं ये, राइजिंग लोअरिंग? भाई कोई लैंडफॉर्म राइज कर रहा है. लैंडफॉर्म कोई अखबार के कागज की तरह नहीं है, नीचे से पूरा सॉलिड होता है. ये हवा में राइज नहीं करता है. मतलब एंटायर सॉलिड लैंडफॉर्म इज अपलिफ्टिंग. मतलब अखबार को ये सोचते हैं हवा में पतला दिखता है ना, दैट इज ऐसे. देखो entire landform is rising. It is rising at a rate of 10. Within this, rivers are carving out their valleys, and this rate of deepening of valley within this landform is 2 centimeter, and rate of upliftment of landform is 10 centimeter. It is thick. It is very thick. उसी लैंडफॉर्म में तो रिवर वैली बना रही है अपनी. As the landform rises, slope comes into existence, rivers carving out their valleys, but the rate of upliftment of landform in first phase, according to Pank, is far more than the rate of deepening of valley. So, in between valleys, these what summits will come into, water divides will come into existence. Since summits of water divide are not eroded, they will continue to rise with the rate of landform. But since rivers are carving out their valleys within this landform, and this rate of deepening of valley is 2 centimeter, and the rate of rise of landform is 10 centimeter, that means valley bottom are also rising. Are you getting this? So, in first phase, तो होता है also relative relief भी बढ़ती है because summits are not getting eroded, valley is deepening. So this distance will go on increasing. This distance relatively बढ़ेगी, clear है? River will continue to river will continue to deepen itself, but the overall valley bottom will rise. But the difference between and summit is rising at rate of 10, valley bottom is rising at rate of 8, because valley is also deepening at rate of 2. So distance will go on increasing between summit and valley bottom. So this graph, these two lines goes on widening. Therefore, the relative relief goes on increasing. Now, ये सब मत लिखना. दिस फेज इज कैरेक्टराइज्ड बाय डीप नैरो वी शेप्ड वैलीज. ये सब मैं बताऊंगा अगले टॉपिक में. आई विल डिस्कस. इन दिस फेज द वैलीज आर convex shape. Why convex? I'll discuss. Now, second phase, glitch formage. It is termed as phase of uniform development. Phase of uniform development. Uniform development का मतलब है when evolution of landform stops. It appears to have stopped. Suppose in this phase what I have discussed, it is a phase of uniform development. That means in this phase the rate of erosion of summit is equal to rate of erosion of valley bottom in each of the 3 subphases. Glitch formage is termed as phase of uniform development because in this phase, in each of the 3 subphases, the rate of erosion of summit and the rate of erosion of valley bottom is equal. Why it is called phase of uniform development? इसलिए suppose this is mountain and this is valley. ठीक है? This is summit and this is valley bottom. If both are eroding at the same rate, then the slope evolution will stop. ऐसा लगेगा लैंडफॉर्म इवोल्यूशन स्टॉप हो गया है. तुम शादी करके 1 लाख साल पहले गए तो भी तुम्हें रिलेटिव रिलीफ उतनी मिली. 2 लाख साल बाद गए, रिलेटिव रिलीफ उतनी मिली. 3 लाख साल बाद गए, रिलेटिव रिलीफ उतनी मिली. बिकॉज द रेट एट विच द समिट इज इरोडिंग एट द सेम रेट वैली इज डीपनिंग. इन दिस केस द स्लोप विल रिमेन कांस्टेंट. स्लोप इवोल्यूशन विल स्टॉप. Although landform evolution is taking place, but slope is not declining. भाई इट इज कॉल्ड फेज ऑफ यूनिफॉर्म डेवलपमेंट. ऐसा लगता है जैसे लैंडफॉर्म डेवलपमेंट स्टॉप हो गया है. स्टॉप नहीं हुआ है, इट इज गोइंग ऑन. बट सिंस रेट ऑफ इरोजन ऑफ समिट एंड रेट ऑफ इरोजन ऑफ वैली बॉटम इज इक्वल इन ईच ऑफ द 3 फेजेस, अगर दोनों बराबर नीचे जाएंगे तो द स्लोप इवोल्यूशन विल स्टॉप. For slope evolution to take place, the rate of erosion of summit should be more. Then only slope decline will take place. Slope evolution will take place only when summit lowers faster. Then only the slope will decline. Slope evolution will take place. If both summit and valley bottom are lowering at the same rate, then the slope will remain constant. That means landform evolution ऐसा लगेगा जैसे stop हो गया है. भाई प्रीवियस टाइम आई टोल्ड यू स्लोप इवोल्यूशन क्यों होती है. when the steepness will decline, then only slope will evolve. लेकिन in this phase what is happening, the slope remains constant, relative relief remains constant. If the rate of lowering of summit and the rate of lowering of valley bottom is equal, the distance between them will remain equal or not? If the rate of, this is summit, rate of erosion of my head, this is summit, and this is valley bottom, rate of erosion of valley bottom, both is same, then the distance between them will remain same. Suppose I am in a lift. I am in a lift. See, still landform is rising. Landform is rising at a slow rate. Lift rise कर रही है. Lift रुक जाए या lift नीचे जाए. If the rate of erosion of my head and rate of erosion of my hand, इन दोनों का rate बराबर है, तो distance between these two will remain same whether I move landscape rises, landscape stop और लैंडस्केप नीचे धंसने लगे, लेकिन डिस्टेंस बिटवीन माय हेड एंड माय हैंड विल रिमेन सेम. भाई भले लैंडफॉर्म राइज हो, ये भी राइज होगा, ये भी राइज होगा, इन दोनों में डिस्टेंस इस बात पे डिपेंड करेगी. रेट ऑफ इरोजन ऑफ समिट इज इक्वल टू रेट ऑफ इरोजन ऑफ, जिस रेट से लैंडफॉर्म राइज कर रहा है उसी रेट से समिट इज राइजिंग, उसी रेट से वैली बॉटम इज राइजिंग. बट हियर समिट वाज नॉट गेटिंग इरोडेड, valley bottom was getting eroded, so distance between summit and valley bottom was increasing. Now in these three phases the summit starts getting eroded. और मजेदार बात यह है, in each of the three phases the rate of erosion of summit and the rate of erosion of valley bottom in each of the three phases is equal. यहां पर क्या था, summit was not eroding, valley bottom was deepening, land भले लैंडस्केप ऊपर जा रहा था, द डिस्टेंस वाज इंक्रीजिंग, जैसे मैं लिफ्ट में ऊपर जा रहा हूं. नाउ व्हाट इज हैपनिंग, लैंडस्केप इज अपलिफ्टिंग स्लोली, लैंडस्केप अपलिफ्टिंग स्लोज डाउन, लैंडस्केप स्टार्ट गोइंग डाउन. लैंडस्केप कुछ भी करे, द डिस्टेंस बिटवीन माय हेड एंड माय हैंड, इफ बोथ आर इरोडिंग एट द सेम रेट, वेदर इन अ लिफ्ट आई एम गोइंग अप, आई एम स्टॉप्स, लिफ्ट स्टॉप्स, और लिफ्ट गो स्टार्ट्स गोइंग डाउन, द डिस्टेंस बिटवीन माय हेड एंड माय हैंड विल रिमेन सेम और नॉट? In uniform glitch form is the rate of erosion of summit and rate of erosion of valley bottom in each of the three subphases remains same. As a result, the distance between summit and valley bottom remains same. As a result, relative relief remains this distance, this distance, this distance. This will remain same. If rate by which the summit is getting lowered and the rate by which the valley is deepening is same, then the distance between summit and valley bottom will remain same. This distance will remain same. ये समझ में आ रहा है? तो नहीं आ रहा है तो घर पे फिर से समझना. देखो बेटा, ऐसा है ना, तो खून पी लिया तुम लोगों ने, ऐसा इसमें कुछ भी नहीं है. इट इज वेरी सिंपल, यू जस्ट टेक इट लाइटली, डोंट टेक इट. बल ये सोचो, जैसे अब मैं इसको समझाता हूं फर्स्ट फेज को, फर्स्ट सब फेज. आफ्टर दिस, इन सेकेंड फेज, रेट ऑफ अपलिफ्टमेंट स्लोज डाउन. Penck says although rate of upliftment slows down, but in subphase A the rate of upliftment of landform is still more than the rate of erosion of summit. क्यों है ऐसा? पेंग जाने क्यों है ऐसा. पेंग कह रहा है ऐसा क्यों हो रहा है, ये नहीं सोचना है. पेंग जो कह रहा है वो, पेंग सेज इन द फर्स्ट subphase although upliftment of the landscape slows down, but still the rate of upliftment of landscape is more than rate of erosion of summit. अब summit का erosion शुरू हो गया. Second subphase में he says rate of erosion of summit has started and rate of erosion of summit is equal to rate of erosion of valley bottom. Both summit and valley bottom were getting uplifted. देखो ये मोटा लैंडस्केप है, मोटा, इट इज राइजिंग. यहाँ पर ये समिट है, इसे काट दो कैंची से तो ये वैली बॉटम है, ये समिट है, ये वैली बॉटम है. वैली बॉटम और समिट दोनों लैंडस्केप में ही तो हैं, बोथ आर राइजिंग. अब रेट, ये समिट है, मान लो ये कैंची से काट दिया, ये वैली बॉटम है, ठीक है. वैली बॉटम एंड समिट आर बोथ ऑन लैंडस्केप. अब लैंडस्केप का ऊपर उठना कम हो गया. In first subphase, he says, but in first subphase, he says erosion of summit begins, but the erosion of summit and erosion of valley bottom both is equal. Suppose both are eroding by 2 centimeter per year. But in first subphase, the overall rate of upliftment is more. So what will happen to summit and valley bottom? Rate of erosion of summit, suppose it is 2 centimeter per year. इसी लैंडस्केप, ये लैंडस्केप है ना, दिस लैंडस्केप इज राइजिंग एट रेट ऑफ 3 सेंटीमीटर पर ईयर. ऑल्दो यहाँ पर 10 सेंटीमीटर पर ईयर था, यहाँ पर धीमा हो गया अपलिफ्टमेंट, बट द रेट ऑफ अपलिफ्टमेंट इन फर्स्ट सबफेज अकॉर्डिंग टू पेंक इज स्टिल मोर देन द रेट ऑफ इरोजन ऑफ समिट. तो मान लेते हैं लैंडस्केप के रेट का अपलिफ्टमेंट 3 सेंटीमीटर पर ईयर है, एंड it is more than the rate of erosion of summit, and rate of erosion of summit is 2 centimeter per year, and rate of erosion of valley bottom is also 2 centimeter per year. So both summit and valley bottom will rise or not? अरे भैया मैं अपना नोट्स फाड़ तो दूंगा नहीं तुम्हारे लिए. समझ लो, कैंची से काट दिया है, ये समिट है, ये वैली बॉटम है, और ये पूरा लैंडस्केप है. वैली बॉटम एंड समिट बोथ आर पार्ट ऑफ लैंडफॉर्म, बोथ आर पार्ट ऑफ लैंडस्केप. एंटायर लैंड, ये विड्थ दिखाई दे रही है, विड्थ ये पूरा अंदर तक है, जमीन ही जमीन है, पूरी जमीन, हवा नहीं है कुछ. पूरा लैंडस्केप राइज करता है, तो नीचे से पूरा लैंडस्केप राइज करता है. उसमें रिवर को डीपन होने की बहुत कैपेसिटी स्पेस है. लेकिन अब क्या है कि अपलिफ्टमेंट पूरा, ये पूरा सॉलिड है, ये पूरा उठ रहा है, इसमें समिट है, इसी में रिवर अपनी वैली डीपन कर रही है. इन फर्स्ट सबफेज द रेट ऑफ अपलिफ्टमेंट ऑफ लैंडस्केप इज मोर than the rate of erosion of summit and rate of erosion of valley bottom. If rate of upliftment of this landscape is 3 centimeter per year and the rate of erosion of summit is 2 centimeter per year, तो summit ऊपर जाएगा कि नीचे जाएगा? इसी में river valley है, rate of erosion of summit is equal to rate of erosion of valley bottom. Valley bottom is also eroding at rate of 2 centimeter per year, and but overall it is rising at rate of 3 centimeter per year. लैंडस्केप में ही तो है, तो वैली बॉटम विल ऑल्सो राइज. दिस अपवर्ड स्लांट इंडिकेट्स दैट समिट्स आर राइजिंग. दिस upward slant of lower curve indicates valley bottom is rising, both are rising, but the distance between summit and valley bottom remains same because both summit, ये लैंडस्केप तो राइज कर रहा है, लेकिन इन दोनों के बीच की डिस्टेंस, द रेट ऑफ इरोजन ऑफ समिट एंड द रेट ऑफ इरोजन ऑफ वैली बॉटम बोथ इज इक्वल. सो द डिस्टेंस, रिलेटिव रिलीफ रिमेन्स कांस्टेंट. देयरफॉर द डिस्टेंस बिटवीन दीज टू लाइन इज कांस्टेंट. ये ध्यान रखना है. बोथ लाइन्स आर मूविंग अप बिकॉज द रेट ऑफ ओवरऑल अपलिफ्टमेंट इज मोर. So summit is also uplifting, valley bottom is also uplifting, and since the rate of erosion of summit and valley bottom is equal, so the distance between them remains same. So these two lines will always be parallel. तो इसमें क्या लिखेंगे? Absolute relief क्या होगा? बढ़ेगा. Relative relief constant. इन दोनों की distance constant है. Valley bottom बढ़ेगा. Valley bottom is rising, summit is rising, absolute relief is rising, valley bottom is rising, but the distance between them, that is relative relief, remains constant. If relative relief remains constant, distance between constant, slope evolution stops. ऐसा लगता है कि landform evolve ही नहीं कर रहा है. Therefore, it is said phase of uniform development. Second phase, second subphase. Here, Penck says rate of upliftment exactly matches with rate of erosion of summit and rate of erosion of valley bottom. In second subphase के end में upliftment will stop. In this second subphase, Penck says rate of upliftment is exactly equal to the rate of erosion of summit. जिस रेट से upliftment हो रहा है उसी रेट से summit erode हो रहा है. What will happen? ना ऊपर जाएगा ना नीचे आएगा. In this subphase, the rate of upliftment of landscape, जिस रेट से landscape rise कर रहा है ना, उसी it slows down to such an extent that rate of upliftment of landscape is exactly equal to rate of erosion of summit. मतलब लैंडस्केप का रेट का अपलिफ्टमेंट 2 सेंटीमीटर पर ईयर है और समिट का रेट ऑफ इरोजन 2 सेंटीमीटर पर ईयर है, तो समिट कहाँ जाएगा, ऊपर जाएगा कि नीचे जाएगा, वहीं रहेगा। इट विल, देखो इट इज नॉट, तभी तो ये एग्जैक्टली पैरेलल हॉरिजॉन्टल, rate of erosion or rate of upliftment is exactly equal to rate of erosion of summit. Rate of, suppose erosion of summit is 2 centimeter per year, then upliftment is also 2 centimeter per year. Valley bottom में क्या होगा, valley bottom is also eroding at the same rate 2 centimeter, इसका भी upliftment 2 centimeter. Valley bottom will also not rise. So these two lines will be perfectly horizontal. That means absolute relief constant, relative relief constant, valley bottom constant. ना समिट राइज कर रही है ना वैली बॉटम राइज कर रहा है, क्यों, द रेट ऑफ अपलिफ्टमेंट ऑफ लैंडस्केप एग्जैक्टली मैचेस विद द रेट ऑफ इरोजन ऑफ समिट एंड रेट ऑफ इरोजन ऑफ वैली बॉटम. सो एज अ रिजल्ट एब्सोल्यूट रिलीफ, relative relief and valley bottom, absolute relief will constant, valley bottom will remain constant, neither rise nor fall. And relative relief, it depends upon the rate of erosion of summit and valley bottom, that is always equal in all the three phases. So relative relief will remain constant. Here upliftment stops. अब लैंड का अपलिफ्टमेंट स्टॉप हो गया. Summits are getting eroded. अपलिफ्टमेंट रुक गया है, समिट्स इरोड हो रहे हैं, तो व्हाट विल हैपन टू एब्सोल्यूट रिलीफ, अपलिफ्टमेंट रुक गया, अब अपलिफ्टमेंट हैज स्टॉप्ड, समिट्स आर गेटिंग इरोडेड, एब्सोल्यूट रिलीफ विल डिक्रीज. ये नीचे की तरफ लाइन आ रही है ना, एब्सोल्यूट रिलीफ विल डिक्रीज. व्हाट विल हैपन टू वैली बॉटम, the rate at which summit is eroding, at the same rate valley bottom is eroding in each of the three subphases. So upliftment has stopped, valley is also getting deepening, so valley bottom will also lower. देखो नीचे line is lowering, this means valley bottom is lowering from base level, its height is decreasing, valley bottom decreases. What happens to relative relief? भाई वो तो नहीं बेटा, if the rate of erosion of summit and rate of erosion of valley bottom, suppose I am in a lift and lift stops and the rate of erosion of my head and my hand valley bottom continues at the same rate, then the distance between them will remain. Therefore in these three subphases both the lines are of equal distance because the distance between summit and valley bottom is not changing. Here also the relative relief will remain constant. Since the relative relief remains constant, relative relief distance between summit and valley bottom remains constant. In that case, slope evolution stops. Therefore, it is known as phase of uniform development. Evolution हो रहा है, but slope is not declining. यार कॉन्सेप्ट तो अब समझाना था मुझे, मतलब अब तक तो ये फालतू सिंपल टिप थी, अब ये बताना है. जैसे डेविस ने कहा था, now onwards Davis said slope decline takes place by way of down wasting. अब इसका बड़ा मैप बनाना है थर्ड वाले का. Peng says no, slope decline takes place by way of slope replacement from below. अब ये कल समझाएंगे यार तुम लोग, ये समझ आया. यही तो मेन पार्ट था जिसमें मुझे पूरा टाइम देना था समझाने के लिए, इसको मुझे बड़ा सा बना के समझाना था. व्हाट इज एक्चुअली स्लोप रिप्लेसमेंट फ्रॉम बिलो. डेविस कहते हैं ना, इट इज डाउन वेस्टिंग दैट लीड टू लैंडफॉर्म इवोल्यूशन, स्लोप गोज ऑन डिक्लाइनिंग. पेंग सेज नो, until Inselberg is there, slope decline will take place by way of slope replacement from below. Once the conical Inselberg is removed, thereafter the slope decline will take place by way of down wasting. This is what I had to explain in the entire lecture. लेकिन यहाँ तक पहुँचते पहुँचते 1.5 घंटा लगा दिया तुम लोगों ने, तो इसमें कितना लगाओगे. इसको समझना है क्योंकि अगले चैप्टर में, नेक्स्ट चैप्टर में समझना ही पड़ेगा. स्लोप डेवलपमेंट में आई विल डिस्कस द सेम थिंग कि what is slope replacement from below. Down wasting clear हो गया. When the rocks when the summits are lowered by way of weathering of rocks, and rocks fall down under the impact of gravity, and the height of the summits gets lowered, that is known as down wasting. This down wasting is the result of mass wasting and the slope declines. वैसे ही इनका एक कॉन्सेप्ट है Penka that I have to explain. Slope replacement from below. If this is the slope, then this is the entire slope. Then from bottom, a gentle slope will come into existence. Rest of the segment will move parallel to itself. Again, a gentle slope will come into existence. Rest of the segment will move parallel to itself. Again, from the bottom, a gentle slope will come into existence. Rest of the slope will move parallel to itself. And ultimately, this will be replaced by this. This is how this slope gets reduced into this slope. The slope angle declines. यही समझाना है ये क्यों होता है, why it happens. भाई देखो, अभी जो समझाया है ये कल समझ के आना. ये जो चीज मुझे समझानी है ना, ये अगले चैप्टर में भी समझानी है और यहाँ पर भी समझानी है. What is Inselberg, what is Andrum, how Andrum extends at the cost of, how Heldenhang extends at the cost of Boschungen. अगले चैप्टर में हम लोग हेल्डेनहैंग को कहेंगे रेक्टिलियन स्लोप, बॉस्चुजन को कहेंगे फ्री फेस. यही कोरिलेट कराना ना, जैसे तुमको चीजें बहुत क्लियर होनी चाहिए अगले चैप्टर से पहले. दीज थिंग्स शुड बी वेरी क्लियर. अच्छा, इसमें बताओ ये सेकंड फेज समझ में आई? थर्ड फेज में ऐसा कुछ भी नहीं है. इन थर्ड फेज बेसिकली अपलिफ्टमेंट तो स्टॉप हो गया. दिस इज थर्ड फेज. In third phase, everything is visible. It says it is phase of decelerating development. अब next topic बढ़ाऊंगा. When upliftment stops, rate of valley deepening by river depends upon rate of upliftment. It is the rate of upliftment that determines the rate of valley deepening by river, and it is the rate of valley deepening by river that determines the nature of slope. Davis कहते हैं valley deepening or erosion begins only after upliftment is complete. Pang says no, erosion does not begin after upliftment is complete. Rather, it is the rate of upliftment that determines the rate of erosion. And it is the rate of erosion that determines the form of slope that will be created, whether convex slope, rectilinear slope, or concave slope. अब ही सेज हियर इन लास्ट फेज, जैसे कि इसमें और डेविस में एक ही चीज कॉमन है. इन लास्ट फेज और इन लास्ट स्टेज, वेदरिंग इज द फिनोमेना दैट इज टेकिंग प्लेस. रिवर वाटर डज नॉट प्ले एनी रोल. लास्ट फेज उनका अपलिफ्टमेंट स्टॉप हो जाता है यहां पर. यहां से डेविस शुरू करते हैं. डेविस स्टार्ट्स फ्रॉम हियर व्हेन अपलिफ्टमेंट इज कंप्लीट. आर यू गेटिंग इट? ही हैज स्टार्टेड फ्रॉम प्राइमरम. So don't try to compare. But in his third phase also, upliftment तो stop हो चुका है. Now in this phase, valleys are very broad. Rivers, water is flowing somewhere in between. Only weathering is phenomena. Landscape evolution is taking place only by way of weathering. And since at the end only very hard and resistant rock remain behind, and weathering is very slow phenomena, so this phase is very long and the process of evolution is very slow. Because जब upliftment हो रहा था, river was actively deepening. अभी पढ़ाएंगे, upliftment slows down, valley deepening slows down, and here when upliftment stop, very hard and resistant rocks remain behind, and the only phenomena which is responsible for landform evolution is weathering. So landform evolution is very slow. तब कैसे से, इसीलिए से कहते हैं phase of decelerating development or waning development. Yes, the evolution takes place very slowly. In this phase, lateral erosion again. This is river valley. These are water divides. अब इसको बड़ा करके बनाते. In this phase, lateral erosion remains dominant. Valley widening continues. क्यों? Not because river water is flowing somewhere in between, merely because of weathering. Merely because of weathering is again taking place because of mass wasting. Here also, just like in Davis. In old stage in Davis, river valleys become very wide and graded, and water divides are in the form of gentle swells. Here also valleys are so wide that water divides are part of valley side. They become part of valley side. Valley side का एक valley side कैसी होती है? This valley side is somewhat like this. This is, yeah, somewhere here water is flowing. Here you will see, here you can make it out. This segment of valley side is having gentle slope, and the segment which is forming water divide, whether the water divide is part of valley side, this is having steep slope. This steep segment of the valley side is known as Boschingen. This gentle segment of the valley side is known as Heldenhang. इसी को आगे चल के विल डिस्कस एज फ्री फेस और एक्लिनियस सरफेस. आई विल डिस्कस. Valley sides are very broad. Water is flowing somewhere in between. The process of landform evolution is weathering. Weathering means weathered sediment. जैसे weathered sed पहले क्या हो रहा था? Weathered sediment gets weathered. डेविस के केस में, and weathered sediment falls into the river, and as a result of this mass wasting, what is happening? It is lowering in height, that is down wasting. It is narrowing down, that is back wasting, and river valley is widening, that is lateral erosion. यही तो डेविस में बताया था मैंने. As the weathered sediment fall under the impact of gravity, that is mass wasting. This fall under the impact of gravity, that leads to lowering of summits, that is down wasting, narrowing down of summits, that is back wasting, and widening of valley, that is lateral erosion. वही अब हो रहा है. But he says, Davis says, until the Inselberg, steep conical Inselberg is there, he says, same process, weathered sediment will fall, but not the way Davis is saying. It will fall in a different way. He says, ये है ना, अब कल दोबारा भी पढ़ाऊंगा तुमको, एक बार और पढ़ा देता हूँ अभी. He says, this is river valley, this gentle, ये छोटा स्पेस है, बड़ा बनाते हैं उसको, तो ऐसे बनेगा. ये रिवर है, दिस इज जेंटल सेगमेंट, सपोज दिस इज स्टीप सेगमेंट. ही सेज एज द सेडिमेंट, जैसे ये पूरा ये है, ही सेज ये जैसे वाटर डिवाइड है, दिस इज स्टीप सेगमेंट ऑफ वैली साइड बॉस्चिंजन, दिस इज जेंटल सेगमेंट ऑफ वैली साइड हेल्डेनहैंग. ही सेज बिकॉज ऑफ वेदरिंग, वेदरिंग होगी, and weathered sediment, this will weather, and weathered sediment will fall. This weathered sediment will, weathering हुई, this weathered sediment will fall. He says in the upper sediment, एक मिनट, जैसे ये sediment है, this has got weathered, this sediment will weather and fall, but some sediment will remain deposited at the bottom. It will not fall into the river because of lack of requisite mobility. This sediment will remain deposited at the bottom. He says this entire will weather, but the upper sediment, because of steep slope, it will fall into the river, but this sediment at the bottom will remain deposited, it will not fall. Why? Because of lack of slope, lack of mobility. As a result, this will be replaced by, you will see this Heldenhang will gradually extend, and you will see this slope is replaced by a gentle slope from below, and then this upper segment retreats parallel to itself, and at the bottom this is replaced by a gentle slope. And as this gentle slope extend, and the size of water divide goes on decreasing. The Boschigen of the adjoining valleys retreat back. These Boschigen of the adjoining valley retreat back because of weathering of exposed rock, and these Boschigen retreat back by way of slope replacement from below. As these Boschigen retreat back, they intersect, and because of intersection of these Boschigen, the water divides goes on decreasing in size, and ultimately they are reduced in the size of Inselberg. And as the Boschigen retreat back, the length of Boschigen decreases and Heldenheim extends at the cost of Boschigen. अब कल पढ़ाऊंगा इसको, ठीक है? ये तुम लोग पहले इतना कंफर्म करो, इतना क्लियर हुआ, ये तो मैं समझा दूंगा क्योंकि अगले चैप्टर में भी है. बिकॉज व्हाट हैपेंस कि ये इट इज़ वेरी सिंपल. तुमको ये क्वेश्चन नहीं करना है कि ग्लीच फॉर्मेज की फर्स्ट फेज में वाई अपलिफ्टमेंट इज मोर देन इरोजन. भाई डेविस का पेंक का कहना है, मान लो उसने स्टडी किया है, ये स्टडीड इन ग्लीच फॉर्मेज सेकेंड स्टेज अपलिफ्टमेंट इज इक्वल टू इरोजन ऑफ समिट. वाई नहीं करना, इरोजन इक्वल टू, सो समिट विल नॉट राइज, नॉट लोअर, लाइन इज स्ट्रेट, and difference between summit and valley bottom in each of the three subphases will remain same. अच्छा, तुम में से कितनों की समझ में आ गया ये? लिगो क्लियर? यस करण, ठीक है, तो इसको और क्लियर करो. तुम लोग बोला करो ना, हाथ तक आ गया तो मुझे कॉन्फिडेंस आएगा थोड़ा, वरना टीचर का भी कॉन्फिडेंस डगमगाने लगता है. पता नहीं समय मैं ही समझ में भी आ रहा है कि मैं ऐसे ही बड़े, मैं तो इसको खत्म कर देता अभी. लेकिन इट इज़ वेरी इंपॉर्टेंट टू, बिकॉज दिस टॉपिक इज इंटरलेटेड विद नेक्स्ट टॉपिक विच इज इंटरलेटेड विद नेक्स्ट टॉपिक. कहीं भी फंसे तो आगे जाकर के फिर फंसोगे, राइट? टुमारो विल अगेन कंटिन्यू सेम, द थर्ड फेज आई विल स्टार्ट अगेन, राइट? ओके बेटा, ओके बेटा, वेलकम, वेलकम बेटा.